Hey guys, so this week you guys are going to be looking at dot plots and histograms, and also we're going to look at some box and whisker plots. So these are all three different ways to organize data. So I'm going to draw both a dot plot with this data on the screen and also a histogram. So basically someone asked the question, how many siblings, what's the number of siblings that's in your family, to third period students, and these were their responses. So to make a dot plot, you're going to draw what is just like a number line from the smallest to the biggest number. So our smallest number is 0, and our biggest number I see is 6. 1, 2, 3, 4, 5, 6. So even though every number is not represented, since just like a number line, you don't skip numbers, well, neither do you do that on a dot plot. Now, some people will try to go through and count up all the zeros and count up all the ones and the twos, but it's easy to miss a question, or excuse me, it's easy to miss a number when you do it like that. So you're just going to draw your number line, and then you're going to put an X or a dot over each number the way they're written in order. So here we're going to do a 2, 1, 2. So 2, 1, 2, 3, 1, 2, 3, 1, 2, 1, 0, 2, 1, 0, 2, and I didn't realize there was a 7. The next number is 7, 7, 5, 3, 7, 5, 3, 7, 5, 3, 1, 1, 1, 1, 1, 1. And then I have 2, 6, 3, 2, 6, 3, 2, 0, 4, 2, 0, 4, and then 1, 1, 3, 1, 1, 1, 3, 1. All right, so if I wanted to go, you always go back and count how many numbers you started with and then how many you recorded, okay? So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. So each X, or if I use dots, I could have used dots. Each dot or each X represents a person that was asked. So my dot plot, if I want to see how many people were represented, I'm going to count the number of X's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I know I have all of the numbers represented. Now we would say that this dot plot is asymmetrical. It's not symmetrical, it's asymmetrical. Symmetrical is if you basically had a uniform curve, like a bell-shaped curve that was a mirror image from the middle on both sides. But this one is what we call skewed right because it kind of trails off to the right. We don't really have any outliers. So an outlier is a number that stands far apart from the rest of your data. There are no outliers because there's no gap in our dot plot. We do say that we have a peak at 1, so we can definitely tell that 1 is the mode, the number that occurs the most. If we want to know what the median is, we'd have to write these numbers out in order and find the middle number. Or we could count. We know 25 is an odd number, so there's one middle number. It would be number 13 on my list in order. We can find the mean from this set of data because we know how many people are involved. And so we can figure out the mean, median, mode. We can find the range, the smallest and the biggest numbers, the difference between the smallest and biggest numbers. All right, so there's a lot we can tell from a dot plot. Now, a dot plot, obviously we listed out our responses individually. If we wanted to create a histogram, histogram's frequency is always a set of intervals. So we might want to might want to group these numbers by sets of 3. And even though there's not an 8, we want to make our intervals consistent, so we'd have 3 digits per group. So on our dot plot, we would, on the bottom, we would put our intervals. So we want 0 to 2 siblings, and then we'd put 3 to 5, and then we'd have 6 to 8. Whoops. Let me erase this. So this is how you guys would make both a dot plot and a histogram. Figure out what your intervals are. They have to be consistently grouped intervals. Now, we want to use our entire dot plot. Now, even though we asked 25 people, we don't necessarily need to number through 25. We want to take our most popular response, and that needs to be our highest number. So obviously our most popular response is going to be 0 to 2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we probably should have even put this in groups of 2. But anyway, so since 17 is our biggest number, we could probably count by 2s up to number 18. So we can do 2, 4, 6, 8, 10, 12, 14, 16, 18. Now, if we were in class, I would tell you guys to take your time, space those out consistently. You want the same amount of space between all of your intervals. You know, we would do this with rulers. Of course, obviously, we don't have that luxury doing virtual, but anyway. So histograms look a lot like bar graphs, except the bars all touch each other. So my most popular response was 17. So we're going to make our bar go all the way down here. We would use colored pencils or crayons, and we would fill this in nicely. Obviously, I'm doing it kind of quickly, so mine's not going to be the neatest graph you've ever seen. All right, now make sure you always want a title for your graph. You want to also label what these numbers represent and what these numbers represent. So since these represent the number of people we asked, we can call this frequency. And these are the number of siblings. And my title of my graph could be the question, basically, how many siblings do you have? Number of siblings per student. All right, so then our next group has 1, 2, 3, 4, 5, 6. So I would probably change colors if I was, you know, doing this and I wanted it to look nice. I would try to make my bars about the same. I didn't make this one quite fat enough, wide enough. I'd probably make that one a little wider. So 6 people responded that they have 3, 4, or 5 siblings. And then we only have 2 students that have 6 through 8. So we'll do light green. All right, and I should have these should be better spaced out on the bottom too, okay? So my histogram looks a lot like a bar graph. The bars are touching. On the bottom, we have intervals of numbers. On the y-axis, we have frequency. Now, if we didn't have this data up here and we didn't have this dot plot, one disadvantage of a frequency table is I wouldn't be able to tell how many students have exactly one sibling, right? I would know that 17 has either 0, 1, or 2, but if I didn't have my data here or my dot plot, I wouldn't know how many students have exactly one sibling. So since I couldn't figure that out, you know, it would be hard for me to figure out what the mean is because I don't see any of the specific numbers, right? I could tell you the range of the middle number, the median. I could tell you the range, but I wouldn't be able to tell you the exact median. So it's a good way of representing data, but sometimes histograms don't give us all the information we may need. It's just more of a general idea of how the data is distributed. All right, so there are some vocabulary terms you need to be familiar with the dot plots. The first one is the word peak. So that's the value in the data set that occurs the most often. So here, once again, we would have a we have a graph that skews to the right because it kind of goes, oh my goodness, because it kind of flows down this way and kind of tapers off to the right. So this skews right, but we would say that it has a peak at 2 because 2 is our most popular response. It is our mode, right? All right, what else? A cluster, a group of data points gathered around a specific value. So this isn't really a big cluster. I mean, this basically is all of our data except for one piece up here, which is probably considered an outlier as far away from the rest of the data. But let me show you this graph right here. So we do have a low point and a high point way out here, but then most of the middle part of the data is clustered from 4 to 6. Do you see that? All right, what about a gap? So obviously a gap would be a large space between data points. So here we have a little bit of a gap. Here we have 2 responses, but here there's no responses from 9 to 11. So there's a gap in our data. And if we talk about a graph looking symmetrical, that means that we're kind of going to see this kind of a bell, you know how a bell that you can ring looks, the top of the bell. So it says a distribution that can be divided at the center so that each half is a mirror image of the other. So this is very symmetrical. It looks exactly the same on both sides of the peak. Now, it doesn't always have to look like a mirror image. You can look, if there was one less 20 right here, we would still say that that would be a normal distribution of data. So there's not a big discrepancy. There's not a huge peak. There's not a gap. There's not an outlier. Those words could be changed, be used interchangeably. All right, so sometimes a dot plot is best to use and sometimes a histogram is best to use. So if you have data like this, like here is our data and this is the number of people that would respond to these scores, then obviously these numbers are all very close together. There's not a big gap between them and there would be no need to make intervals. Like look at this set of data over here. The data is varied, meaning that there is a big difference between the low score and the high score. There's a big spread. And so instead of having to list those points, all those different scores individually, we group them into intervals. So anytime you have intervals like these scores, you definitely would want to use a histogram. If you have numbers that aren't too spread out, they're pretty close together and there's not like, 100 different students that are being represented, a dot plot would be easy to show that data on. All right, so you guys are going to do this sheet. I think this is Wednesday's assignment. How do you repair a broken tuba? And this time, I don't want you just to figure out the punchline of the joke. In fact, I don't care if you even figure it out because you don't need to tell it to me, but I want you to create histograms on this paper that you will, you can either download it and write directly on the PDF, or you can print it out and write with a pen or pencil, and then take a picture and share that with me because I do want to see your histograms, okay? All right, so what you're going to do is you're going to take each of these data sets and you're going to make a tally mark, or this is one full data set. There's 40 different responses in this one data set. And you're going to take each of these scores and you're going to make a tally mark to represent each of them. So for the number 80, this one student scored an 80. I'm going to do a tally mark right here. For 71, that would go in the same section. For 91, I have a tally mark right here. For 64, I have a tally mark here. And you're going to keep doing this. 89 would go here. 99 would go here. 77 here, 85 right here. And you're going to do that for all 40. So at the end, you should have 40 tally marks. Well, then frequencies, you're going to tell me how many tally marks per section. So for example, let's say this ended up being 8. I'm just making that up. I don't know. I'm just making up some responses. I don't know if these are correct. All right, so basically they take your frequency and they've already put them here on your x-intercept. Your x-axis, excuse me. They've labeled it your score, and this is frequency. This should match this. So for 41 through 50, let's say I end up getting 6, which I don't know if that's right. I haven't finished it yet. You're going to go up here to the number 6, and you're going to shade this in. You can use, if you don't have different colors, you could use stars in one, circles in one, lines that go this way through one. But anyway, you want all of your bars to look a little different. And then for the next one, I can just change colors. So I'm going to do my bar up to 5 for this one. I'm going to shade this in solid, so on and so forth. Okay. So that's how you're doing this. So you have a total of, I think, 2. I've lost my paper, but I think you guys are making 2 histograms, or maybe it's 3. I'm not sure. But anyway, you have the sheet. So that's how you're going to do this whole paper. Like I said, you can download it right on the PDF, and then make sure you share that document with me, or literally print it out, write on it, take a picture of it, scan it, and share it with me that way. Okay, so I'm not interested in the punchline this time. I want to actually see your histograms. All right, moving on. Now, when you get to Thursday or Friday, you're going to look at what is called box plots. We can also call them box and whisker plots. The reason it's called that is because this middle section is called the actual box. And then these are called the whiskers. So the whiskers always point to the lowest number and the highest number. The box represents the middle 50% of your data. Okay, so what a box and whisker plot does is it takes your data and it divides it into fourths. So from the minimum value to the lower quartile, this represents 25% of your data. From the lower quartile to the median, that represents 25% of your data. From this section to this section, that represents 25% of your data. And from your upper quartile to your maximum number, that represents the highest 25% of your data. So your box represents the middle 50% of your data. So you can have 1,000 scores, and if you put that information on a box and whisker plot, basically you're dividing your data into fourths. You're telling me quickly how the lower 25% of your people scored, how the middle 50% scored, how the upper 25% scored, so on and so forth. All right, so basically what happens is you take your data, you put it in numerical order, and then this is called a 5-number summary. I want to know what the smallest number is. I want to know what the lower quartile, or Q1, is called, or what number it is. I want to know what the median is. What's the middle number? What's the upper quartile, also called the L3? And then finally, what's the highest number? All right, so let's look at a box and whisker plot. So this is a double box and whisker plot. It shows us how our data is graphed based on, like I said, percentages. So look at test 2. So test 2, there's a much bigger range from the lower quartile to, the lowest number to the lower quartile. That is 25% of your data. And even though this is a shorter range, a smaller whisker, it still represents 25% of your data. Now, one of the disadvantages of a box and whisker plot, if there is one, is that you don't know how many total numbers are represented on the whole box and whisker plot. So with a box and whisker plot, you wouldn't be able to find the mean. You can find the range, you can find the median, you can find that interquartile range, and so we'll talk about all that. So when you have a long whisker, so if this is 50% of your picture and this is 50% of your picture, you would say it's very symmetrical. But this is going to be a little, that kind of looks symmetrical, but it's more skewed left. Whichever whisker is the longest, if it's the left one, you'd say it's skewed left. If your right whisker is the longest, that means it's skewed right. That means there's a greater range in the highest 25% of your data. All right, so for test 1, what is the lowest number? The lowest number is 3. The lower quartile, or the Q1, is 6. The line through your box always points to the median, which is 12. The upper quartile, or the Q3, is 16. And the maximum number is 21. All right, what about test 2? The minimum number is 3, same minimum. The Q1, or the lower quartile, is 9. The median is the same, it's 12. The upper quartile is the same, it's 16. And the maximum number is the same, it's 21. So there is a much bigger range between the lower 25% of data for test 2, and there's a much bigger range for the middle 50% of your data for test 1. All right, so you can see how that's kind of distributed. All right, so how are we going to make a box and whisker plot? Well, the very first thing we're going to do is put these numbers in numerical order. Okay, first thing you do, you must put them in numerical order. So I'm going to count the zeros. 1, 2, 1, 2. Now I'm going to count the ones. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to find the 2s. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now the 3s. 1, 2, 3, 4. 1, 2, 3, 4. Now the 4s. There's 1, 4. I see 2 5s. 1, 2. I see a 6 and a 7. All right, so since we copied down numbers, we always count how many we have and how many we started with. So we have 3, 6, 9, 12, 15, 18, 21, 24, 25, 26. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Good, so we have the right number. Now, the first thing you're going to do is figure out where the median is. Well, since there's an even set of data, they're going to have 2 middle numbers. So it's going to be lower 12 and upper 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, what? Oh, it's 13. Duh. It's not 12, it's 13. It's still between 2 and 2, isn't it? All right, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 13. I don't know why I said 12. All right, so our middle number is 2. What comes halfway between 2 and 2? It's a 2. All right, now we need our lower quartile. Since we have 13 numbers here, there is only one lower quartile. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, now we make a number line. Now that your data is not your number line. A lot of people make that mistake. They go, oh, well, I'm just going to do my box and whisker plot here. Well, that's not a number line. That's your data. So we're going to draw a number line from 0 to 7. 2, 3, 4, 5, 6, 7. So you guys don't just watch me do this. I hope you're doing it as well. So your box goes from your lower whisker, or Q1, to Q3, your upper whisker. Excuse me, I'm saying the wrong word. Lower quartile to upper quartile. Q1 is your lower quartile, Q3 is your upper quartile. So the middle 50% of my data goes from 1 to 3. Okay, So this is how many siblings do you have? And then the line through your box always points to the median. So that's very symmetrical, isn't it? So the middle 50% of my data has siblings, either 1 to 3 siblings. The lowest number on my data set is a 0. So 25% of my kids, 25% of the people I asked have either 0 or 1 sibling. Well, then from my lower quartile to my upper quartile, look how big this whisker is. We would say this is skewed right because my right whisker is the longest, which probably means that there is there's a big gap between the upper 25%. From 3 to 7, there's only a 1-digit difference between my lowest 25% and my lowest number. And there is quite a big range between my Q3 and my maximum number. Okay, so that shows us how our data is distributed. So the middle 50% of our students have between 1 and 3 siblings. So that's how you make a box and whisker plot. So I want you guys to try it. So I want you to pause the video. First thing you got to do is put these numbers in order. Find the median, find the lower and upper quartiles and the smallest and biggest numbers, and then you're going to make your number line. All right, so pause me and try it out and let's see what you get. 49, we have a 50, we have a 55, we have a 65, 65, 65, 65, 66, 68, and now I have a 70, a 70, 70, 70, 74, 78, 79, and 80. Did y'all count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's one middle number. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. And then my lowest quartiles between 55 and 65. So if I add those together and divide by 2, I get 60. And then my upper quartiles, that's my lower quartile, my upper quartiles between 74 and 78. If I add those together and divide by 2, I get 76. That's my upper quartile. Now I need to number from 49 to 80. So I'm probably just going to start with 48 and count by 2s. 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, and 80. All right, so our box goes from lower quartile to upper quartile, 60 through 76. That's the middle 50% of our data. The line through our box is going to be pointing to 68, which is our median. And then our biggest number is 80, and our smallest number is down here at 49. All right, so that's how you make your box and whisker plot. Any questions? Hope you guys got it right. All right, now an outlier is a number that's set far apart from the rest of the data. So for our dot plot here, we have the numbers are clustered up here between 5 and 7, and then we have an outlier down here by itself. So an outlier is always going to affect the mean the most. So if we figured out the mean of these numbers, it's going to be 6, but then if we threw in that outlier, it's going to drop our mean. So it looks like overall people spent less time at field day than they actually did because of that outlier. Well, same thing with this. The number of pies that got thrown at the principal per person, well, between 1 and 4 is where most of our responses is is, but then we had one person that threw either 9 or 10. So when we found the mean and we are going to add in that big number, it's going to make it look like people threw more pies than they actually did. So when you're talking about the middle part of your data, if there's an outlier present, you're going to want to use the median. If the outlier is not present, you're going to want to describe the average as the mean. Okay. So here are some graphs that's skewed, like I was talking about. The histogram is skewed right because it kind of trails off down here to the right. This dot plot is also skewed right because it kind of trails off here to the right. This box and whisker plot, it's got a long right whisker, so it's skewed right. And then the rest of these are skewed left, obviously. This kind of drags on down here off to the left, right? This has got a big part of 50% of the data. This is a lot bigger than this part right here. So even though the whisker is not longer on the left, it's skewed left because it's so not symmetrical. It's so not, sounds so weird. It isn't symmetrical. Neither one of these are, right? And then we would say that this histogram is skewed left because it trails off to the left. So some of these are going to show us that there's an outlier. So this looks like it probably is an outlier. This looks like an outlier. And normally, if you have a skewed graph, usually an outlier is present. It doesn't have to be, but these two statements are correct. When an outlier is present or the data is skewed, you want to use the median to find the best measure of center and the interquartile range to find the best measure of spread. When the distribution is symmetric or a normal distribution, that's when you can use the mean to find the best measure of center. And then last week we talked about the mean absolute deviation. That would go along with the mean, that middle part of your data. All right, so the interquartile range, I don't think I talked to you guys about that. So to find the interquartile range, you know how we're finding the lower and upper quartiles? The interquartile range is the difference between the lower quartile and the upper quartile. So we have our upper quartile or quartile 3, and from that we're going to subtract our lower quartile, also called quartile 1. And here we have 16 points. That is the interquartile range. So that's how far spread the middle 50% of our data is. That's why it's called the interquartile range. Okay, I know that's a lot, but you're going to need that. You're going to repeat this again in 8th grade and then again in high school. And so this stuff is something that should become very familiar to you because you're going to get a little bit of it each year and it builds on itself every year. All right, you guys, I hope that helped, and you guys are going to get your work done this week. If you have any questions or need my help, just let me know and I'll help you any way I can. Have a